I would like to start today's video by warning you about a chemical that is commonly found in ponds, lakes, rivers, and oceans. Dihydrogen monoxide, or DHMO. DHMO is associated with many issues: health, environmental, and technological. Inhaling it causes death, and its vapors can cause severe burns. It has been found in biopsies of cancerous tumors and lesions, and has been consumed by vicious dogs involved in deadly attacks on humans. DHMO is a major component of acid rain and is known to contribute to soil erosion. It has also been associated with hurricanes and deadly storms in Florida, New Orleans, and other areas in the Gulf of Mexico region. Finally, DHMO leads to corrosion of many metals, causes contamination and short circuits in electrical systems, and causes a decrease in the effectiveness of automobile brakes. Activists in the media have brought the hazards posed by DHMO to public attention on multiple occasions. However, the substance is still widely available around the world, including in the US. There is a good reason for it. You see, dihydrogen monoxide is the chemical name for water. All the facts that I listed are true. Indeed, if inhaled water causes death by drowning, hot water vapor can cause nasty burns, and water had been consumed by every animal on Earth, including vicious dogs that attack humans. In 1997, Nathan Zoner, then a junior high student in Idaho, presented this fact sheet on DHMO to 50 ninth graders, and 43 spoke in favor of banning the substance. It is not just teenagers who have fell for the joke. Whenever some media outlet publishes these facts, as on April Fool's jokes, local governments receive multiple calls from concerned residents, and even members of parliament in a number of countries had voiced concerns about the chemical. The reason for this confusion is straightforward: unfamiliarity with chemical nomenclature, the systematic rules that chemists use for naming compounds. While many common chemical compounds have common names like water and table salt, the variety of compounds is so great that using arbitrarily chosen names for them all is impossible. Therefore, the International Union of Pure and Applied Chemistry, the same organization that approves the names of chemical elements, established rules that assign each compound names based on what atoms the compound is made of and how these atoms are connected to each other. To those familiar with this nomenclature, the systematic name of a compound provides complete information about its chemical composition and structure. The chemical nomenclature, of course, can be applied to compounds that have common names as well. So you might hear chemists calling table salt sodium chloride, or calling baking soda sodium hydrogen carbonate. Although few people will call water dihydrogen monoxide except as a joke, it is a technically correct name. Because of the variety of chemical compounds, the complete chemical nomenclature is rather complex, and even professional chemists sometimes have trouble correctly naming or interpreting the names of large and complicated molecules. However, the rules for naming a wide variety of compounds that we will be dealing with in this course are straightforward. Let's learn these rules. The first thing that we need to know is that the rules are different for molecular and ionic compounds. Before naming a chemical compound, we need to establish whether the compound is ionic or molecular. Remember, compounds that include atoms of both metals and elements that are not metals are by and large ionic. Compounds that are entirely made up of atoms of elements that are not metals are typically molecular. We will learn about a few exceptions to this rule in the next lecture. The rules for naming binary molecular compounds, that is, compounds that are composed of atoms of two chemical elements, are the simplest. The name of such compounds has the following structure: a prefix that indicates the number of atoms of the first element in the molecule, followed by the name of the first element, followed by a prefix that indicates the number of atoms of the second element in the molecule, followed by the name of the second element with the ending of its name changed to "-ide". The prefixes that indicate the number of atoms of the elements are the following: mono meaning 1, di meaning 2, tri meaning 3, tetra meaning 4, penta meaning 5, hexa meaning 6, septa meaning 7, octa meaning 8, nona meaning 9, and deca meaning 10. You should remember these prefixes. If the number of atoms of the first element in the molecular formula is 1, the prefix mono is omitted for this element. However, even if the number of atoms for the second element in the molecular formula is 1, the prefix mono is retained for this element. Let's look at a few examples. The first one is the compound that consists of molecules made of one carbon atom and two oxygen atoms. The molecular formula of this compound is CO2. It is a molecular compound because both carbon and oxygen are nonmetals. Therefore, the naming convention for molecular compounds applies. Let's use this convention. Because there is only one atom of the first element, carbon, we do not need a prefix that indicates the number of atoms for this element. So we start with the name of the element, carbon. Because there are two atoms of the second element, oxygen, the prefix that indicates the number of atoms for this element is di. This prefix is followed by the name of the second element, modified so that the ending is "-ide", so oxygen becomes oxide. Now we put all the parts of the name together and get carbon dioxide. Similarly, the name of the compound that consists of molecules made of one carbon atom and one oxygen atom is carbon monoxide. This compound has the formula CO and is also molecular, so the naming convention for molecular compounds applies. The first two steps in naming the compound are the same as for carbon dioxide. Omit the prefix for the first element because there is only one atom of it, and start with the name of this element, carbon. For the second element, use the prefix mono because there is one atom of it, and modify the name of the element oxygen to end in "-ide", oxide. The complete name of the compound is then carbon monoxide. Following these rules, we can deduce that the name of the compound that consists of molecules made up of two nitrogen atoms and one oxygen atom is dinitrogen monoxide, two nitrogen atoms and one oxygen atom. Similarly, the systematic chemical name of the compound that consists of molecules made of two hydrogen atoms and one oxygen atom is dihydrogen monoxide, although we commonly call it water. Of course, the second element in the compound doesn't always have to be oxygen. If the second element is nitrogen, the name of the compound will end in nitride. If it is sulfur, the name of the compound will end in sulfide. If it is fluorine, chlorine, or bromine, it will end in fluoride, chloride, and bromide respectively, and so on. The last question that we need to address is which element should come first in a chemical formula, and consequently in the name of a compound. Convention assigns the following priority to elements. Carbon comes first, then hydrogen, then elements in the order from the left to the right within a period, and from the bottom to the top within a group of a periodic table. That is, if a molecule is made of carbon and another element, carbon will always come first, as is the case in carbon monoxide and carbon dioxide. If the molecule is made up of hydrogen and another element other than carbon, then hydrogen will come first. This is the case for water, H2O. If a molecule consists of atoms of two elements within the same period, then the atom that is further to the left comes first. This is the case for dinitrogen monoxide. If a molecule consists of atoms that are within the same group, such as one sulfur atom and one oxygen atom, the element that is lower in the group will come first. The formula for this compound will be SO and the name sulfur monoxide. If the elements that the molecule is made of are neither in the same period nor in the same group, then the element that is farther to the left in the periodic table typically goes first. For instance, the molecule that consists of one sulfur atom and two fluorine atoms has the formula SF2 and is called sulfur difluoride. In the next video, we will talk about naming ionic compounds.